afternoon. So this project was mentioned before, client-side data compression. So it looks like Lustre users want this feature because I see that somebody even invent its own compression. Of course, I understand this for other goals, but probably having the general feature that can be used elsewhere can make their life better. So let me introduce this feature and describe its advantages. So first of all, why we have chosen client-side compression. So there is not a problem, there is a feature of the Lustre, then a lot of clients can write and read data to or from server at the same time. In this case, a lot of data to the network, and finally a lot of data is being written to the disks. So how we can improve, how we can write even more. So the first solution could be compress data on the server side. In this case, the same amount of data arrives to the server. So this why this left network is red here. So then server compresses data. It spans its CPU, and the more clients we have, the more CPU spent. So probably this could be a problem at some moment. But we can compress data and save it in a more efficient way. So, but the best solution is allow a client to compress their data themselves. So in this case, they compress data and send this data to the network already compressed. So the throughput become even bigger, and finally, server do not spend its CPUs. And finally, we have data compressed and can store more data. So finally, this project happened. So client-side data compression. So its advantages are it is transparent completely for user. So the only thing is needed. Administrator sets rules and configure. And finally, client or user just write to the data and read it, and even do not know that it is finally compressed. The same features as it used to see before, all of the features there in this compression. So it's very simple. It is extendable. So currently there are 4 compression algorithms: LZO, LZ4, LZ4 high capacity, and gzip, but they can be expanded later. So there is infrastructure to this, not a problem to it. Also, as data compressed on the client side, it is scalable there. So assume a lot of clients are writing to the same file, so they can do at the same moment. So it's scalable. And on the client side, all CPUs are used because every request is compressed separately, so it's scalable there. No changes in the LDiskFS structures required. Same for ZFS. So as I said that it's simple to use. 2 commands only: LFS set stripe, LFS get stripe. So as it done before, to set configuration for component, additional option is Z. There we set algorithm name and algorithm compression level. And also, you can set compression chunk. So compression chunk is a very important parameter there, because the more compression chunk is, the better data is compressed. But at the same time, probably having compressed chunk too large is problem for small files. So it's very flexible. You can set not only one component per file. The clearest example there, we set no compression for first 500 kilobytes, then we set LZO till 700 kilobytes, and after this point, everything is compressed with LZ4 and level 5. Also, we can set these parameters for directory, and any file that created there inherits these parameters, so any files there will be compressed. And LFS getStripe now shows additional information about compression. So we see LZO and LZ4 parameters there in the output, so file is ready to be compressed. So another change that LFS find is change it a little bit to be helpful to check information about compression. So we can find any file that has compressed components, any file or directory that will be compressed. So there are 3 examples. First of it is find all files that have compressed data. Second one is any layout that are ready to be compressed, and final one show me any file that LZ4 compressed but has compression level less than 6. So this can be used to find such files and probably to recompress it. So a little bit details, technical details. So Lustre use cache buffers, and at the moment it wants clients want to flush this data. All this data is split to chunks, and every chunk is compressed separately. So after compression, we have less data. We need to add a header there, and then this data sent through the network, and on the OST side is stored to the disk continuously without these gaps, but accessed by original offsets. So holes or spare file is used on OST. So this is all transparent and finally works well. So this works well. Then we reading or writing chunk aligned buffers, but there are special cases. Then we want to rewrite chunk partly. Because LustreFS is quite complicated client, we cannot be sure that we always have all data for chunk. And in this case, we need some interaction with a server. So this scheme is quite complicated, but I want to say that this happened not every operation, but only if someone wants to rewrite a chunk particularly. So if somebody writes or read chunks aligned, no such happens. But in this case, this also works. So need to say that here server side is a little bit involved, spend its CPU, but to avoid, as I mentioned, user can send data chunk aligned, and in this case all data is compressed and decompressed completely on the client side. So, and at the bottom shown the case probably for future, then all data can be compressed on the server side in case we will need it, because now we have such an infrastructure to extend this feature to have server-side compression. So we tested it, used sets of data, different kind. First of all, we compared with simple compression on the user mode and have quite the same results, but with cool feature, Lustre FS features. So compression ratio depends from data source. It's obviously compress text well and cannot compress already compressed data. It uses CPU, but this delta that added to the just no compression case not so large. So we are going to release it in 2.17, and module functionality was already finished. Currently optimization, stabilization, and some testing. That's it. Thank you very much.
Yeah, I think if there's a question from the floor, I can see Brian, if you just wait for the microphone.
Thank you. That's great. I don't know if you saw my talk, but I'm clearly very interested in you having the decompression in your storage. You talked about compressing.
Of course,
yes.
Transparent, because just write or read.
But in the server as well as the client, yeah?
On the client. But the server is processing corner cases only.
Okay, but that means you've at least got the libraries there. I'm intrigued at the selection of compression algorithms. What was behind the choice of compression algorithms?
So this algorithm is being written to the components and will be used later. Then data will be written to the file. So we just set up a component, and then it will be used. Something. And as test results shown, it's very important to choose right compression algorithm for different data types.